Okay, so hello everybody. We are finally live for our Hangout number 5. I'm Lucia, the community manager, and we are here with Asier, one of the scientific responsibles for the HIV Science MOOC. So we're very glad to have everyone here today, and we hope we have a very enriching discussion on all the very interesting themes related to the whole HIV. We didn't receive any questions in particular, but we did receive some comments on specific topics that you would like us to address. So I think we can start right into it. So we're going to start by talking about the different mechanisms HIV, the virus, uses to hide in the human host.
Thank you. So hi everybody. Perhaps we should clarify, because sometimes there is this difficulty about defining the HIV reservoirs and how this virus is going to escape from the host, from the surveillance of the host, and even from antiretroviral treatment. So perhaps a few concepts. So the HIV is going to insert its genetic material into the genome of the cell that is going to infect, and this genetic material of the virus may be transcribed directly. So the virus may multiply, make copies of the genetic material, and then replicate, produce viral particles and replicate. But HIV may also stay integrated in the genome of the cell in a latent state. So from there, the virus is not transcribed and is silent. And the virus can persist in this way. Obviously, because the virus is not transcribed, there is no antigens, fragments of the virus that will be exposed, and the immune system cannot recognize the cells that are carrying this latently infected, these latent proviruses. So this is one way the HIV may escape surveillance by latency and being silent and escaping the action of immune effector cells. Then, because HIV is going to infect multiple cells from the immune system, the virus is going to be able to disseminate throughout the organism, and can infect cells in deep tissues. And actually, we can identify infected cells in almost any tissue that we are going to study in the organism, which makes sense because, as I said, immune cells are trafficking all over the body to find pathogens, and the HIV is going to exploit that to disseminate through all the organism. What is not clear today is whether in some of these tissues the antiretrovirals that are very efficient to block viral replication may not be so efficient, because the concentration of the molecules may be a little bit weaker in some of the tissues, and maybe some low-level viral replication. So in these tissues, there may be what we will call anatomic reservoirs, which not only the latently infected cells may persist because they are ignored by the immune system, and they are not touched, obviously, by the antiretrovirals that do not eliminate the infected cells, but also some of the tissues may be some degree of viral replication that may help the virus to persist. And then there are other mechanisms that are also addressed in the MOOC, that are more related to how the virus is going to escape the immune system, how the virus is neglected or has adapted to the cells to avoid some of the defenses that the cell has devised to contract viral infections. But this is another topic.
Okay, thank you very much. Very clear answer. So before continuing, let's just mention that everyone that is right now live in the Hangout, you can leave our message, questions, or comments in the live chat, and we will address those as well. We will move now to the second topic we will be addressing today, which is the reservoirs, the natural reservoirs or natural hosts that carry the virus persistently and live happily with it, let's say.
Yes, so Again, there may be some confusion between the natural hosts that are considered biological reservoir and the cellular reservoir that we just mentioned that is going to harbor the proviruses and favor the persistence of the virus into the infected organism. So natural hosts are in particular African primates that have adapted to coexist with the virus. So the natural hosts get infected with the simian variant of HIV that is called simian immunodeficiency virus. And the particularity of these animals is that they do not develop the disease. The virus is, you can find it at high levels in the plasma, but some of the negative effects of the infection they are avoided by these natural hosts. In particular, these animals are able to control the pathogenic inflammation and immune activation that is characterized by HIV infection and SAV infection in Asian macaques, for instance, that may develop AIDS. And it is believed that this is a very important difference between the natural host and the pathogenic model of SAV and HIV infection. In particular, the work that has been conducted, Michaela Müller-Turtun here at Pasteur, the other co-director of the MOOC, has recently shown that the natural hosts, even if they do not control viral replication throughout the body, they preserve viral replication in the lymph nodes, and this is a critical region of the immune system where most of the reservoir is going to be established in the first wave, where all the immune responses are going to be trained, and preservation of these lymph nodes appears critical, hence to coexist with the virus, and this is why the natural hosts are doing. Perhaps just to clarify that these natural hosts and what we call controllers or macaques or human controllers of HIV are quite different. The natural hosts, as I say, they're going to control the virus specifically in some tissues, while the natural controllers are very rare individuals who can control viremia systemically all over the body.
Okay, and I have a question. Is it clear what mechanisms these primates have to control and coexist with the virus and not develop the disease compared to the human, or that is not clear yet?
Well, there are some studies again. We believe that the significant part is to control immune inflammation during the chronic phase, and we know that uncontrolled immune activation is associated with pathogenesis and decrease of CD4 T cell counts and progression to disease. In the particular case of, for instance, African green monkeys, that is one of the natural hosts of SAV, Michaela's work recently has shown that there is a particularity in these animals is that they can some of the immune effectors that are called natural killers, NK cells, they have the ability to go into the follicular zone of the of the lymph nodes, where actually the antibody response is going to be generated, and apparently they can control the infection there. These natural killer cells, there are signals that drive them there, and then the pathogenic models, these NK cells cannot enter this zone. And we know that this is a very important part of where the virus is going to replicate, because some of the major sites or the major targets for viral replication are focused there. So apparently these animals are able to direct some of these immune responses to this area and efficiently control viral replication there. But obviously this is just one first important clue. We need to understand why, how, and whether this is all, and we need further mechanisms.
Okay, very interesting. So we also had comments and a lot of people pointing towards with very optimistic tone, pointing towards the use now of antiretrovirals that really can control the infection, has significantly improved the life expectancy and span of people that contract the virus. But someone else was pointing out as well as how important is the early detection of the virus in relation to the antiretroviral therapy.
Yes, this is actually probably one of our major objectives in the very short term. Antiretrovirals are very efficient, not only because they can preserve the health of HIV-infected individual, but also because very efficient antiretroviral treatment can can avoid transmission of the virus. So when people are with controlled viremia, they cannot transmit the virus. The difficulty is that many people being diagnosed with HIV, they are diagnosed very late. And the very few months, the very first months after HIV infection, what is called a primary HIV infection, they are particularly a key moment or a special moment to initiate this treatment, because the levels of the virus are going to be extremely high. The risk of transmission is also increased during this period. And if we cannot diagnose people early and put them on therapy very early, not only there are negative consequences, so the earlier you treat somebody, the better he's going to or she is going to be afterwards, because we preserve all the immune system and also we decrease the number of infected cells. But also when we treat very early, we can stop the critical early moments in which the risk of transmission is more elevated. So even if we have objectives to get 90% of people diagnosed as a first step, then 80% people of those on treatment, etc., the issue is going to be always this 10% of this percentage of people who are missed, who are not diagnosed, who are not put into treatment, and who can, unfortunately and unknowingly, drive the epidemic by transmitting the virus that is going unnoticed.
And there is no symptoms, right, at this very critical early stages?
So, yeah, during the very early phases, HIV infection may be symptomatic. The difficulty is that some of these symptoms may be confounded with other common infections, like a lot of people relate the symptoms associated with HIV, acute HIV infection, to flu symptoms. So this is something that both people who may get exposed to HIV, but also clinical people, obviously they are aware of that, is that while when there are some kind of symptoms, you should wonder about the kind of activity that you were exposed to, and think that what you think that maybe a flu, well, depending on the exposure that you may have had to the virus, within 2, 3, 4 weeks, you may be experiencing symptoms related to HIV infection. In other cases, the acute HIV infection may be unnoticed also because it's asymptomatic, which also makes things more difficult to go to get tested. And another difficulty that is a major difficulty, again, is the to be afraid of being tested, because HIV is still a very stigmatized and discriminating infection, and this is an issue all over the world.
Yeah, and so once you contracted the virus, very rapidly you can detect it, or it goes unnoticed for the test, serological test, no? Is it?
Yeah, so there is an eclipse phase in which you cannot detect the virus, but new generation of tests may give you positive results within 3-4 weeks after infection.
Yeah, that's important as well. If someone is suspicious, that maybe, to go and get tested at the appropriate time. So this is all we had concerning the main comments we got in the discussion forum. I don't know if you would like to discuss anything else or add anything else.
No, perhaps just some comments that I received are not related to the MOOC, but as how research on HIV works is. Some people are asking us when you develop some work, how long will be till this is applied, or and I think that it's important to understand that there are some that the research has some steps that we cannot jump, and even when you do translational research, is a very big gap between the experiments that we do in the laboratory, then test some of the concepts in preclinical models, and then go into to clinical research. And obviously, for each of these steps, there are not only conception of research, there is also getting funding, getting approval, ethical approval, in particular when you are using samples from HIV-infected individuals, from a study in animal models of infection, and even more to get to the clinical trials. So at the end is advancing the concept of the research, then getting the money to do that, getting the approval, and then actually the actual results. And within all that, there is the dissemination of all research, which is also an important step, because if we cannot communicate our research, we won't get the funds. So unfortunately, it's not something that we have a clue in the lab, and we are very excited, and we can test it immediately within a few days. So yeah, I know that sometimes it's disappointing.
Yeah,
but we also want to develop our research in a very good pace, but also in a safe way for everyone.
Of course, that is fundamental, especially if you want to move after to other trials. Okay, so just a reminder, the Hangout will be in our YouTube channel, and I will post it as well in the Hangout part of the MOOC. So if you want to go back to it, or if you want to advertise it to other colleagues that maybe missed it right now, remember that you can go back and see this exact same live transmission afterwards. And of course, if you have any other questions that arise from this discussion, or from the classes, from following the MOOC, or in any, as Asier was sharing with us, any other questions you may have in talking to people or professionals, anything, please send us those questions to us so we can address them in the next Hangout session.
Okay.
So thank you everyone for joining. We're very happy to do this, and I hope everyone got a chance to enjoy it as well, and be better informed, and have a more comprehensive understanding of the disease. And till the next time, right?
Yeah.
Bye.
Thank you. Bye.